Now see here hypermetropia, that is long sightedness. Actually in this defect a person can see far off object clearly but cannot see nearby object clearly. As we know, least distance of distinct vision for normal eye is 25 centimeter. Suppose this is the other for this least distance of distinct vision, and the image of the object is formed on the retina and we can see clearly. But defective eye, in which case actually the decrease in the size of the eyeball and increase in the focal length, because of this reason the image of this object which is at the point N is obtained beyond this, behind the retina. You cannot see this object clearly. But the object, if it is at this point N dash, then easily the image can be seen on the retina, or the image is obtained on the retina. It means in this case the near point of the eye has increased, it is from N to N dash, it is more than 25 centimeter. Now when we put the convex lens over here, we can correct this. By putting the convex lens, the object which is at here at this point, which is at the new near point, its a image, at the near point, the image of this object can be obtained at the N dash, and then the eye lens can easily see. So we can correct this defect by using a convex lens of the suitable focal length. So in hypermetropia, basically the causes are very important, like one is the decrease in the size of the eyeball and increase in focal length. Then all these three ray diagrams. And how do we calculate the focal length of the required lens? Now we can see. Now see here, suppose the the near point of this one normal eye has changed. In that case, suppose u is equal to here minus t, that is actual distance. But now you cannot see at this object distance, so we call it that is a hypermetropic eye. And v is equal to here, suppose that is minus x at the new near point, and we can write 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon f is equal to 1 upon minus x plus 1 upon d, and we can write 1 upon f is equal to here x d is here, and we can take here d minus x, and in that case f is equal to x d upon d minus x. This is the new focal length. So we can calculate the focal length of the corrective lens by this way.